I'd like to welcome you all to this series entitled Azure Networking Fundamentals for IT Professionals. In this series, we'll be discussing some of the network functionality which Azure provides. The main focus of this series is on the virtual private network aspects of Azure. We'll be starting with the basics and moving on to creating a multi-site VPN, which is the latest tool in our Azure VPN toolbox. So who am I? My name is Aaron Farnell and I am a technical engineer for Provoke Solutions, and you can find me in our Wellington office. I started my career out in the data center space where I spent a large part of my time working with core network and server infrastructure. I've been able to take those network and server skills and then apply them to the Azure services space. These skills allow me to understand hybrid network environments, and during the series I'll be passing this knowledge on to you. So what's coming up in this series? We have broken the series down into 4 modules. In the first module, we will be covering the basics of VPNs and the various types of Azure VPNs which are available. We'll also be covering off the prerequisites for multi-site VPNs. In the second module, we'll be planning our deployment. Here we will make preparations for deploying our VPN. In the third module, we'll be creating a multi-site VPN. This is where the fun begins. We'll take everything that we have learnt and then apply it to creating a multi-site VPN. In this module, there will be a number of demos which will help you to understand the process. In the fourth and final module, we'll be looking at testing and monitoring our VPNs. I will show you how to deploy an Azure virtual machine and have it appear in the correct network. Then we'll do some basic connectivity tests and cover off some of the ways we can monitor our VPN. In this module, we'll be starting with the basics of VPNs and building upon this to give a good understanding of how we can utilize Azure network functionality in a hybrid environment. A hybrid environment is when we have an on-premises network and then leverage Azure by joining the two networks together via a VPN. The main focus of this series is to create a multi-site VPN between a number of separate sites which will then be connected to Azure. In this module, we will be covering the basics of VPNs and the roles they play in a hybrid network environment. We're going to start with the basics to give everyone an understanding of how these technologies work and how we can implement them in our organizations. First, we'll be covering off the basics of VPNs. Here we will be discussing why we should use a VPN, what a VPN is and how they work. So what is a VPN? VPN stands for Virtual Private Network and can be described as a tunneling technology which creates a tunnel between 2 points across a network such as the internet. This tunnel is encrypted, meaning that the communication sent across it cannot be read if intercepted. Most VPNs in use today are IPsec VPNs, which means they are encrypted using a pre-shared key or certificate. Pre-shared key VPNs require the use of a password which both parties must know. This type of authentication can be compared to using a wireless network where you must know the password in order to connect. Certificate VPNs use certificates in place of a pre-shared key, and these are used to authenticate the two endpoints. For this series, we'll be dealing with pre-shared key VPNs and not certificates. So the first question we should ask ourselves is, do we need a VPN? The answer to this question will be something along the lines of, we need to connect two sites together and this needs to be done securely and independent of protocol. So therefore a VPN is a good solution. We use VPNs because they offer us the security to transfer data knowing that it cannot be read if intercepted, which also reassures us that the data remains private and confidential because we know that the data cannot be manipulated and then sent on. Due to the ease of setting up a VPN, this allows us to scale our organization quickly and efficiently. This makes VPNs a convenient solution. An example of why we would need a VPN is, our company has 2 offices in different locations, and they need to connect both sites in a simple, secure, and cost-effective way. The answer to this problem is to use a VPN as it fits all the requirements. As long as we have an endpoint at each site which is capable of VPNs, then we're ready to go. So how do they work? A VPN works by establishing a connection between 2 configured endpoints. The traffic at one end enters the tunnel unencrypted, then is encrypted and passed along the tunnel. When it arrives at the other end, the traffic is decrypted by the receiving endpoint and then sent on to its destination. When you first configure a VPN, you need to set a number of different variables. These are the main ones that you'll need to know. The public IP address of each VPN endpoint, the networks which are on each endpoint and which ones need to traverse the VPN. A pre-shared key. This is essentially a password which both endpoints must know, and you should follow the password best practice. Endpoints need to connect to each other in order to establish the VPN. To do this, we need to know the public IP address of each endpoint. At the site of each endpoint, there will be other networks which we may or may not want to send over the VPN. We need to know what networks we want to go across the VPN are so we can tell the endpoints which networks to route across the VPN and which to ignore. These are referred to as the remote networks because they exist on the destination endpoint and not the source endpoint. The pre-shared key is an important requirement as it ensures that only known parties that know the pre-shared key can connect to the VPN. This, coupled with the correct IP address, means your VPN will only establish if the IP addresses are correct and both endpoints know the pre-shared key. Think of the pre-shared key as a password, as that is what it resembles. An example of a VPN is, a user sitting in the corporate headquarters connects to a server hosted at the data center. The data is transmitted through the corporate headquarters local area network and is destined for the VPN. The headquarters VPN device encrypts the data and then passes it through the tunnel to the VPN device at the data center side, where it is decrypted and then sent on to the destination server. The user can now access the resources provided by the server. In this section, we will be talking about what an Azure site-to-site VPN is and how they work. Before we get into what they are and how they work, let's discuss why we should use one. So why should we use one? Say you have an Azure subscription with some servers in Azure, or you want to move some of your on-premises servers into Azure. You will need a method of joining your on-premises with Azure. For this, we have an Azure site-to-site VPN, which allows this to be achieved easily. It will allow your Azure services to become part of your infrastructure environment without exposing them to the internet. Here at Provoke, we have a number of servers in Azure, and in order to access these servers, we have a site-to-site VPN set up. This allows us to access the services running on those servers seamlessly, as the network in Azure just appears to the servers as another network which is then handled by our endpoints. This means that there is no extra configuration required on the servers because the servers hosted in Azure appear as if they're part of our local area network. In the next couple of slides, we'll be looking at what an Azure VPN is and how they work. So what is an Azure VPN? An Azure VPN is just another form of IPsec VPN which allows you to connect your on-premises environment to your Azure environment. This is a site-to-site VPN, which means there is only one path to and from your environments. Up until recently, this was the only form of VPN available for connecting on-premises to Azure. Microsoft has released an update which will allow multiple sites to connect to a single Azure network. We'll cover this later. So what can we do with one of these? This will allow us to create a VPN between our firewall and the data center and Azure. The firewall knows about the networks which are in Azure and will then route traffic destined to those networks via the VPN. And any traffic from Azure destined to the networks in our data center will be sent across the VPN via the Azure gateway. So how do these work? There are a couple of components which are part of the process of setting up the Azure side of the VPN. They are the virtual network, the local network, the gateway, and the VPN script. The virtual network is just like a network which you'd find in your typical local area network. It is part of the private address range and has a subnet mask. This allows you to add private IP addresses to your servers and forms part of the remote network for your VPN. A local network is where we specify the public IP address of the endpoint we are establishing a VPN with. It also contains a remote network which can be found at the remote endpoint. This tells the VPN where it may find our on-premises networks. The Azure Gateway is the key part of setting up a VPN. This is where we will find the public IP address of our Azure endpoint and where you will need to configure the type of routing. There are two types of routing to choose from, dynamic and static. Dynamic will allow you to set up multi-site VPNs, and static will only work for site-to-site VPNs. The VPN script is a script which comes pre-configured, and all you need to do is download it and run it against your endpoint device. The script is supported by Cisco, Juniper, and Microsoft. When you configure all these components, they will create your VPN. The process of doing all of this is relatively painless and straightforward. Microsoft have made it really easy to set all this up, and it is all GUI driven, so you shouldn't have to worry about using PowerShell when trying to get the bare bones of it going. PowerShell is required for making advanced changes to your VPN or querying VPN settings. Before a recent change by Microsoft, the only option for connecting your on-premises environment to Azure was by using an Azure site-to-site VPN. This meant that you could access your Azure services over the VPN without too much hassle in configuring it, but prevented people with multiple sites from creating independent connections from each site to a single Azure endpoint. In order to connect more than one site to a single Azure endpoint, the solution was to link all your sites together via VPN and then have a single site-to-site connection into Azure. This meant that all your traffic from the other sites had to route down to your primary site, which had the VPN to Azure. This was not ideal. Microsoft has recently released a change which allows you to add multiple VPNs to one Azure endpoint, thus allowing companies which have multiple sites in different locations to establish VPNs from each location to a single Azure endpoint, instead of having a single site which handled all of the Azure traffic. Here we'll be covering why we would use a multi-site VPN, what a multi-site VPN is, and how these differ from the previously discussed Azure site-to-site VPNs. Why do we need a multi-site VPN, and what does a multi-site VPN provide? It will provide greater site resiliency by allowing multiple offices to connect to a single Azure endpoint. This will reduce the need and cost of having multiple Azure endpoints with duplicate servers for each site. By allowing multiple sites to connect to a single Azure endpoint, we increase the site resiliency by removing a single point of failure which exists prior to multi-site VPNs. So what is a multi-site VPN? With a multi-site VPN, you will be able to connect subscriptions together. An example of this could be that you have a subscription which contains all your production servers, and you also have another subscription which is a DR site. You will be able to connect these two subscriptions together and maintain separately invoiced accounts. This could be useful for splitting out invoices for your accounts department. There may be a requirement to join virtual networks in Azure together. This can be achieved by using a multi-site VPN, or if there are only two, we can get away with using a site-to-site VPN. If we want to join two Azure virtual networks with our on-premises network, then we could leverage a multi-site VPN for this. You may have a number of offices around the world which you want to connect independently to Azure, so users in those offices are able to consume Azure services and servers. An example of this is with Provoke. We have a number of offices around the world which we wanted to connect to Azure via VPN. The problem was the only way of doing this was to create a site-to-site VPN to Azure from one of our sites and then have all the traffic from all the other sites route via the site with the VPN to Azure. This caused issues with latency and resiliency. If the site with the Azure VPN went down, then all the offices would lose their connection to Azure. The solution to this was to implement a multi-site VPN and have each office establish a VPN to Azure, so in the event that the site goes down, at least the other sites will still be able to consume the services provided by Azure. So what are the key differences between a site-to-site VPN and a multi-site VPN? Well, a multi-site VPN will allow for multiple connections to a single Azure network, the ability to connect multiple virtual networks together. A multi-site VPN will also allow for a mix of multiple sites and virtual network connections, and also the ability to connect Azure subscriptions together. Whereas a site-to-site will only allow for a single point-to-point connection between Azure and your premises, or between two Azure virtual networks. There are a number of hard requirements which we must meet before we can even think about creating a multi-site VPN. Firstly, we need a VPN device which supports dynamic routing. There are a number of vendors which are supported. I will note that if you have a Cisco ASA, they do not support dynamic VPN routing. However, their ASR and ISR devices do support dynamic routing. When you go to download the VPN script from Azure, you will find out that it is pre-configured for Cisco, Juniper, and Microsoft endpoints, which makes setup a lot easier. If you don't have a device which supports dynamic routing, you can always deploy a Windows 2012 machine and install the Routing and Remote Access Services feature on it. This is capable of dynamic routing, and it is a product that everyone can get their hands on, as it comes as a role which can be added after you install Windows. Using Routing and Remote Access Services is also a straightforward process to get working without going into a lot of configuration. In fact, the Azure VPN script is capable of doing all the work for you, which saves a lot of time. A public IP address is important, and your endpoint must be addressed this way, and not be hiding behind network address translation. The reason for this is that we need to establish a connection directly to the endpoint. We will need to download the PowerShell for Azure commandlets in order to make some modifications to our network in Azure. Depending on the type of deployment required, we may or may not need to use these. Typically, you would use the PowerShell commandlets to set up a pre-shared key between two virtual networks in Azure if you were joining them together in that manner. You'll need to know or have some knowledge of the addressing scheme of your on-premises networks, as we'll need this information for setting up the remote networks in Azure and on your premises. You'll need Notepad or your favorite text editor. I prefer to use one which has line numbers as it's easy to read. We'll be using this to modify our Azure Network configuration file. This is the key part of making the multi-site VPNs function. So that is the end of Module 1. I'll see you again in Module 2.